Hi, chemistry students. Here we are. We're in the library. Can you tell? How often do you go to the library? And do you know how these books are organized? If you were going to find a book in the library, what would you do to find it? How are books classified? Do you remember that, maybe from elementary school? I know you just go online, but books are actually classified by the Dewey Decimal System. Where would you go to find the science books? Do you know? 500s? 600s? You try next time. Go to the library and check out the science section. You'd be amazed. Well, here we are. We're going to talk about how elements are arranged on the periodic table, just like books are in the library. If you want a couple amusing things, go ahead and watch Jim Lears read or sing the periodic table. Great song. I think I played it on Mole Day for some of you guys. Or, if you're a Harry Potter fan, go watch Harry. Okay, we're going to start with Lavoisier. Lavoisier in 1789 started grouping some of the substances that known to exist. Watch his list. Oops. What you see here aren't all elements, but he didn't know. He said, okay, here's a group of what I think are elements or something like an element. Sulfur, phosphorus, carbon, those are elements. But other things that are used to make acid, let's put them in one section. He wasn't assuming it was a periodic table, but in his mind, he started categorizing what matter existed at that time. Then some of the matter was gas-like. Light, heat, are those elements? No, but he didn't know. He just was grouping things. All matter that existed. Where would you put them? Hey, you see a flame, group it together. A couple more lists. A bunch of metallic things, grouped together. And then a bunch of earthy substances. And once again, whoop, are they elements? No. Let me get my pen out here. These aren't elements, but they are compounds. So Lavoisier wasn't really truly setting out to make a periodic table, but he said, hey, these things I can classify. And how am I going to classify them? Notice these are all compounds, not elements. But that's okay. They had some similarities and he put them together. He had a list of 23 known elements at the time, but something happened in the 1800s. What happened? You know, the Industrial Revolution. And with the invention of electricity, all of a sudden now we have the technology to start breaking down these compounds and making more elements. And Lavoisier's numbers of elements tripled. Whoa, the task of organizing. How was he going to do it? Well, he started by organizing all the elements in their atomic masses. Lightest element here up to the heaviest elements. John Newland had an idea. He came up with a music analogy, the law of octaves. If you look at the periodic table, every 8 element has similar chemical and physical properties. And he thought, wow, every 8th, it's like music. It's an octave. The scientific community, they didn't like that idea. Bad idea. Didn't fly. But if you look at the actual properties, remember the video we saw in class? So we look at lithium, and 8th elements over, the next one under, sodium, has very similar chemical and physical properties. They look similar and they act the same chemically. So he was on to something. Mendeleev took it a step further, and if he started looking at his groupings, even if they had every 8th one, he said every 8th one did have similar physical and chemical properties. And so then when he started organizing, he said, I'm going to skip some, and I'm going to actually leave a blank in the periodic table because we're missing something that doesn't have a property like the one above it. And so in his mind, he started organizing. I'm going to let you watch a video that will help you understand what he was doing. But he actually had this long, involved process. He stayed up for 3 days. He tried to figure it out, and he had a dream. But, again, he was organizing lightest to heaviest by atomic mass, and there's some errors there. This is the modern periodic table, not Lavoisier's. So we have way too many elements here. But let's look at arranging from the lightest to the heaviest, and you'll see in this periodic table there are some mistakes. So Lavoisier was a little confused because he's saying tellurium is a lot like selenium and iodine is a lot like bromine. But the masses don't match. But he did it anyway. So he was following that periodic pattern. And that's important to remember. That's Mendeleev. That's his mug. Let's watch the video, and then I'll come for a moment.
9. Mendeleev had been trying to find a pattern to the elements for a decade. Whatever order he and the world's chemists tried to impose, there were still elements that wouldn't fit. A universal theory seemed out of reach. But now Mendeleev hit on a new idea. He made up a pack of cards and wrote an element and its atomic weight on each one. Strange though this might sound, so began the most memorable card game in the history of science. He called it Chemical Solitaire and began laying out the cards just to see whether there was a pattern, whether it all fitted together. Now, previously, chemists had grouped the elements in one of two ways, either by their properties, like those that react very strongly with water, or by grouping them by their atomic weight, which is what Berzelius and Cannizzaro had done. Mendeleev's great genius was to combine those two methods together. The odds were stacked against him. Little more than half the elements we now know about had been discovered, so he was playing with an incomplete deck of cards. He stayed up for 3 days and 3 nights without any sleep, just thinking solidly about the problem. Then on the 17th of February, with a snowstorm raging outside, he decided to stay at home. He was exhausted, and he finally dozed off. The story goes he had an extraordinary dream. He saw almost all of the 63 known elements arrayed in a grand table which related them together. It was an incredible breakthrough. I can imagine Mendeleev feeling like so many other scientific pioneers. It's that determination, even desperation to crack a puzzle, and then that eureka moment of revelation. Mendeleev had revealed a deep truth about the nature of our world, that there is a numerical pattern underlying the structure of matter. This is the periodic table as we know it today, and it's rooted in Mendeleev's discovery. It decodes and makes sense of the building blocks of the whole world. Now, although it's so familiar to us, it's on the wall of every chemistry lab in every school in the world. If you really look at it, it's actually awe-inspiring. What's so remarkable is that it reveals the relationships between each and every element in order. Mendeleev had brilliantly combined elements' atomic weights and properties into one universal understanding of all the elements.
Okay, what'd you think? Pretty impressive. If you want to read more, I actually have the book in my classroom called Mendeleev's Dream. How he actually came up with it in his dream. That's a true story. So here's the basis of his periodic table. You can see there wasn't much there, but he's got 8 sort of Roman numerals of that repeating periodic pattern. This is what Mendeleev said. If all the elements be arranged in order of their atomic weights, a periodic repetition of properties is obtained. He's very Russian. Okay, but he wasn't exactly correct. As you saw with the periodic table I circled, there were some inaccuracies there. So it wasn't until 1913 that Moseley came along, and he discovered some of these inaccuracies. And he said, what about if we take the periodic table and we rearrange it by atomic number? And then unfortunately he died. Pretty amazing stuff though. And that's really what our modern periodic table is based on. So write this down. When atoms were arranged according to their increasing atomic number, the problems Mendeleev had got solved. So it straightened out all of those masses. So our current modern periodic law states there's a periodic repetition of the chemical and physical properties of the elements when they're arranged by increasing atomic number. So that's big, atomic number. Mendeleev used atomic masses. Moseley, atomic number. And the current periodic table is arranged by their number of protons, or their atomic numbers. There's Moseley's mug. A little bit younger than Mendeleev. A little less hair, too. Okay, so there we have it. Ta-da! Our modern periodic table.